Stroboscope simulation flowcharts. The logic by which Stroboscope performs a simulation is described in a series of flowcharts that appear in an appendix in the Stroboscope dissertation. This flowchart shows the main logic by which Stroboscope performs a simulation. This flowchart shows the initialization of a simulation model, the main simulation loop, and the conditions under which simulation stops. The main simulation loop consists of two phases: the Combi instantiation phase and advancing the clock. Boxes that have double lines at both sides indicate that they represent an additional flowchart at a more detailed level that will be presented later. When simulation starts, Stroboscope sets the simulation time, sim time, equal to 0. It turns on the maybe can start flag for all Combi activities. It sorts all groups of links in the order they were defined. At the beginning of the main simulation loop, Stroboscope evaluates the terminating condition. If it is true, then the simulation will stop. If the terminating condition is not true, then Stroboscope sorts all the combis according to the result of evaluating their priority. If there are any ties, then combis are sorted by the order in which they were defined. Then comes the Combi instantiation phase that will be described later. After the Combi instantiation phase, Stroboscope evaluates the terminating condition again. If it is true, the simulation will stop. Otherwise, Stroboscope will continue by advancing the clock. The process by which the clock is advanced is also described in a separate flowchart. After advancing the clock, the loop repeats by evaluating the terminating condition to see if it is true. The reason for having two tests whether Stroboscope has reached the terminating condition is because the terminating condition can be reached after the Combi instantiation phase. In other words, the simulation could end when a particular activity has started so many times. In that case, simulation will stop immediately after the Combi instantiation phase. On the other hand, simulation could end when sim time reaches a particular value, in which case simulation will end immediately after advancing the clock. This flowchart describes the Combi instantiation phase. At the very beginning, the flag at least one started is set to the value false. After that comes a loop which is controlled by an index or counter, which is shown here by the letter I. I is initially set to 0. After that, I is compared to the number of combis. If I is not equal to the number of combis, then Stroboscope checks to see if the maybe can start flag for Combi I is turned on. If it is not turned on, then Stroboscope increases I by 1 and again examines to see if I equals to the number of combis. If again the answer is no, then the same question is repeated: is the maybe can start flag for Combi I on? If the answer is yes, that means that Combi I could possibly start. So the next box is the attempt initiation of Combi I. This is represented by another flowchart separately. After the attempt to instantiate Combi I comes the question whether the instantiation of Combi I was successful. If the instantiation of Combi I was successful, then at least one started is set to the value true. and then Stroboscope checks to see if the duration of the new instance of Combi I is greater than 0. If it is greater than 0, then Stroboscope will attempt to instantiate Combi I again. If the duration of the instance of Combi I was 0, then Combi instantiation phase stops. This is a very important point because it illustrates that dummy activities that have 0 duration are treated differently from activities that have durations greater than 0. For dummy activities, Stroboscope terminates the Combi instantiation phase immediately so that it can release the resources taken up by the dummy activities in order to be able to start other activities at the same time without advancing the clock. This loop indicates that activity I can create multiple instances, one after the other, without examining other activities whether they could start. Eventually, activity I will not be able to create any more instances, in which case Stroboscope will increment the counter I by 1 and again compare it to the number of combis. By continuing in this process, I will indeed equal the number of combis. In other words, all combis will have been examined as to whether they could start at the current simulation clock. And then a Stroboscope will examine if at least one started is true. If no combi was able to start, then the Combi instantiation phase will stop. If, on the other hand, the flag at least one started is true, then Stroboscope returns and sets the flag at least one started to false and repeats the entire process. This means that Stroboscope will continue attempting to start combis for as long as one of them was able to start. Only when it goes through the entire loop of checking all activities and none of them are able to start will the Combi instantiation phase stop. To summarize, the Combi instantiation phase stops only in 2 cases. The first case is that the activity being instantiated is a dummy activity. The second case is when Stroboscope has called through all the combis and none of them was able to start. The Combi instantiation attempt flowchart shows how Stroboscope determines whether a combi can create an instance. This is a very important flowchart because it is at the heart of the mechanism by which combis can start. The first step is to evaluate the semaphore of the combi. If the semaphore of the current combi is false, then the Combi instantiation attempt fails. Stroboscope will then return to the Combi instantiation phase. If the semaphore of the current activity is true, then Stroboscope starts a loop. This loop is controlled by the counter I. At the beginning, I is checked to see if it is equal to the number of incoming links. If it is not, then Stroboscope evaluates the enough attribute for link I. If the enough attribute for link I is true, then I is incremented to I plus 1. Stroboscope checks to see if it is equal to the number of incoming links, and if it is not, then Stroboscope evaluates the enough attribute for the next link I. If one of the enough attributes for any link I is found to be false, then Stroboscope sets the combi's maybe can start flag to off, and the Combi instantiation attempt fails. If Stroboscope examines all incoming links to the combi, and the enough attributes for all incoming links are true, then the combi is put in context, which means that it is in impending instantiation. Stroboscope then performs all the before draws actions for the Combi. These are all the actions that have been defined to take place before the Combi draws any resources. After that, Stroboscope starts another loop by which it draws resources for each preceding link I. This loop again uses counter I. Initially I is set to 0 and it is compared to the number of incoming links. If it is not equal to the number of incoming links, then Stroboscope performs the draw process for link I. After the draw process for link I is performed, the index I is incremented by 1 and it is again compared to the number of incoming links. This loop continues so that Stroboscope will perform the draw process for all incoming links I for the Combi that has just created an instance. After that, Stroboscope completes the process by which it creates an instance of a Combi activity. At the completion of that process, the Combi activity is put out of context. This is followed by a loop that clears the draw duration statistics for all incoming links I. At the end of clearing the statistics, Stroboscope sets the Combi instantiation attempt for this particular Combi I to be successful and returns to the Combi instantiation phase. In summary, when Stroboscope attempts to instantiate a particular Combi, the result can be one of two. Either the Combi instantiation attempt failed, or the Combi instantiation attempt was successful. This flowchart describes the drawing process for a generic link that connects a queue holding generic resources to a Combi. At the start of the drawing process, Stroboscope checks to see if the predecessor queue is empty. If it is, then the drawing from the queue is complete. If the predecessor queue is not empty, then Stroboscope evaluates the draw until for this link. If the draw until is true, then again Stroboscope stops drawing from the queue. If the predecessor generic queue is not empty, and the draw until for the link is not true, then Stroboscope proceeds to evaluate the draw amount for that link. It then removes from the predecessor queue the smallest of two values. One value is the result of evaluating the draw amount expression, and the other value is the current content of the queue. Stroboscope will remove from the queue the minimum of these two amounts so that the contents of the queue will never become negative. After Stroboscope draws through this link from the preceding queue, it evaluates the draw duration for this link and collects statistics on it. Then Stroboscope performs the on-draw actions for the drawing link. This is succeeded by adding to the successor Combi the amount of resource removed from the predecessor queue. At the end of this, Stroboscope checks to see if the predecessor queue is empty. If it is, the drawing process is again complete. Otherwise, Stroboscope will evaluate the draw until for the link again to see if it is true. This loop continues until either the queue becomes empty or the draw until for the link is satisfied, in which case drawing from the queue is complete. In summary, the draw process ends in one of two conditions, either when the predecessor queue becomes empty or when the draw until for the drawing link becomes true. This flowchart describes how Stroboscope performs the draw or the release process through a characterized link. Notice that the process is the same for drawing links as well as for releasing links. It is important to appreciate that this process describes the drawing or the releasing through a particular characterized link. At the beginning of this process, Stroboscope sorts all the resources that can be drawn or released through this link according to the expression of the draw order or release order statement. This process of sorting the resources or ranking the resources is such that the resource with the lowest value of draw order or release order expression has rank 0. In other words, ranking is such that the resource with the lowest value of draw order or release order expression goes to the front of the line and has rank 0. At this point, resources are sorted in the order in which they will be attempted to be drawn or released. This begins a loop which is controlled by index I. I is set to 0, and then it is checked to see if it is equal to the number of resources of this type which are initially in the predecessor. If they are not, then Stroboscope evaluates the draw until or the release until. If the draw until or the release until is not true, then Stroboscope will cursor the resource ranked I. Then Stroboscope will evaluate the draw where expression for this link. It is important to appreciate that the draw where expression for this link is evaluated for the resource that is currently cursored by the link. If the draw where expression for this link for the resource currently cursored by the link is false, then Stroboscope will increment the index I and Stroboscope will examine the next resource in line. This repeats the loop. If during this loop the draw until or the release until becomes true, then the drawing process or the releasing process ends. If the evaluation of the draw where expression for this link and for the currently cursored resource returns the result true, then Stroboscope will remove the resource ranked I from the predecessor, update the time spent statistics for resources of this type on the predecessor, and for links out of queues only, it evaluates the draw duration for this link and collects statistics on it. Then it performs on-draw or on-release actions for the link, and then Stroboscope uncursors the resource ranked I and sends a receive message to the successor passing the resource ranked I to the successor. Stroboscope then increments the index I to I plus 1 in preparation of evaluating the draw until again, cursoring the next resource ranked I, and evaluating the draw where expression for the next resource. Drawing or releasing resources ends in one of two cases. The first case is where Stroboscope has examined all the resources available for drawing or releasing, and the draw until or the release until has not become true. This means that Stroboscope will examine all the resources in line once to see if they can be drawn. If it reaches the end of the line, and the draw until or the release until have not been satisfied, and Stroboscope has run out of resources to either draw or release, then the drawing or releasing process from the predecessor is complete. The other case where the process is complete is where the draw until or the release until return the value true. The remaining flowcharts examine Stroboscope's logic in more detail and are available in the Stroboscope dissertation. they will not be described in this presentation. Understanding these flowcharts, and especially the first 5 flowcharts that describe the process by which Stroboscope performs a simulation, is key to understanding how to model operations in Stroboscope.